Air masses are large regions of air that have similar characteristics from the surrounding area. Air masses can form over places like warm tropical oceans, cold dry polar regions, or even dry deserts. As air masses move over different regions, they will gradually take on the characteristics of the new region and begin to change. As air masses move across the Earth, they will eventually run into each other. The boundaries between these two air masses are referred to as fronts. Fronts are labeled in reference to the relative temperature of the air that is approaching and replacing the existing air mass. There are 4 types of fronts: warm fronts, cold fronts, stationary fronts, and occluded fronts. A warm front occurs when a warm air mass overtakes an air mass of a colder temperature. Warm fronts usually move slowly, around 10 to 25 miles per hour, and have a gradual slope that will slide over the top of a cooler air mass and move it out of the area. Warm fronts usually contain high humidity and have more stratiform or layered clouds along the frontal boundary. Drizzle and decreasing visibility will be present as temperatures rise. Once the front passes, rain showers are possible, followed by a gradual clearing. A cold front occurs when cold, dense air overtakes warmer air. Cold fronts move faster than warm fronts, averaging 25 to 30 miles per hour, but can go as fast as 60 miles per hour. Cold fronts stay close to the ground and have a steeper angle than a warm front. They will move across the ground and lift existing air at a very rapid rate. This rapid upward motion will cool the air and form cumulus clouds, which could eventually develop into thunderstorms or even form a line of thunderstorms called a squall line. Once the front passes, the weather will clear and improve with general wind flow from the west-northwest. A stationary front occurs when 2 air masses meet, but neither one moves the other out of the way. Stationary fronts can have a combination of weather from both a warm and cold front. These fronts can oscillate, but will generally linger around for several days before one of the air masses pushes the other air mass out of the way. The last type of front is called an occluded front. Occluded fronts form when a fast-moving cold front catches up to a slower-moving warm front. Cold front will then lift up the warm front and eventually interact with the air that is in front of the warm front. This stacking of fronts can give rise to a variety of weather conditions, from fog to thunderstorms.